Hello and welcome back to another video. In this problem, we're told if f of x is equal to ln of x and g of x is equal to x squared minus 9, find the functions f of g, g of f of f, g of g, and their domains. So for all of these compositions, we are going to find the domains by the restrictions that we have on ln of x. This is the only function contained within these functions that has a domain restriction. And it's simply that whatever is inside of the ln at the end of everything that we go through here has to be greater than 0. So with that in mind, we start with f of g, which can be written as f of g of x, meaning we plug in g of x into f of x. So this becomes ln of g of x, which is x squared minus 9. So this is the function. Like I said before, the restriction is that what's inside the ln, x squared minus 9, has to be greater than 0. So adding 9 to both sides, we get x squared is greater than 9, taking the square root. We therefore get that x is greater than 3. And we just have to have also the negative version of that, because negative numbers squared can also be greater than 9. And that just has to be x is less than negative 3. So if this was x squared is equal to 9, x should be equal to positive or negative 3. When you're dealing with an inequality and you have a positive equality with its negative counterpart, you find the point, negative 3, obviously the same way we found positive 3, but just remember to flip the sign. So we have ln of x squared minus 9, where x has to be greater than 3 or less than negative 3. Next we have g of f. This is equal to g of f of x, which means we have to plug in f of x into g. So we have ln of x squared minus 9. And there's no real way to simplify this in any meaningful way. This is not equal to 2 ln of x, right? You can't move the exponent over like you can if it was ln of x squared, because this exponent is outside of the function. But anyway, the domain restriction is, of course, that whatever inside the ln has to be greater than 0, which in this case is just x. Next we have f of f. This is equal to f of itself, f of x, meaning we have to plug in ln of x into x right here. It becomes ln of x. So here we have two domain restrictions. X has to be greater than 0, just like before. But also what's inside this second natural log, ln itself, has to be greater than 0. ln is log base e of x. Therefore, e to the 0 is less than x. Remember, when you are turning a logarithm into an exponent, you have to keep the x on the same side of the inequality. E to the 0 is 1, so this is x is greater than 1, which supersedes x is greater than 0. So our domain is simply that x is equal to 1, is greater than 1. And finally, we have g of g, which is g of x. And this is plugging in g into itself, so this becomes x squared minus 9 squared minus 9. We can simplify this. We have x squared times x squared is x to the 4th, minus 9x squared, minus another 9x squared is minus 18x squared. Negative 9 times itself is positive 81. Then don't forget the negative 9 at the end, meaning we have one last step to get x to the 4th minus 18x squared plus 81 minus 9 is plus 72. And this has no domain restrictions. So we can say all real numbers, and this is our final function. So we have A, B, C, and D. f of g, g of f of f, and g of g, and their respective domains.